YouTube, ooh, I think we're ready. It's time. It's another week of SBAU Astro Hour, everybody, brought to you live on Monday mornings anyway, by your South Coast's longtime telescope and astrophysics club, the Santa Barbara Astronomical Unit. Happily, I am Ron Heron, Vice President of the club and host, inviting members and some stargazing fans who might be on board as future members to SBAU. Watch us on YouTube, 11 to noon on Mondays. This happens to be the 24th of October, and this edition, number 87, runs through next Sunday, which is the 30th. You want to see past programs, go on sbau.org. Episode 87. Man, we're closing in on a second year. Here's what we're going to try to talk about today, everybody. We missed the Mercury occultation of the moon, and we're going to miss an eclipse. And I'm going to ask, what's the difference between an eclipse and an occultation? Lots of clusters to talk about again, including the white rose. Mars is near opposition. Where the heck is Comet C2022E3, huh? The James Webb spots some strange rings. Ooh, and more Orionid meteors at night. Let's meet the gang. President Jerry's running the show as temporary webmaster. How are you, Jerry Wilson?
I'm good.
Can't call you a doctor, even though you have a legitimate PhD. And what is it? Engineering?
Condensed matter physics.
Ah, he's the man. He and Chuck with the answers are both married to a Pat. Pat is merchandise manager for the club. That's Chuck's wife, Chuck McPartland. Our outrageously reachable outreach coordinator, Chuck. Thank you for showing up on screen. Tom Totten is with us, official webmaster for the club, and man who will be hosting next week. We'll may or may not talk about that. And here is Tom Whittemore, married to Maureen, former Westmont College science instructor, who actually chose a musical event over watching the stars on Friday, but that's all right. You can tell us about that later, Tom. I always smell sourdough bread cooking when you get.
Got a good nose today.
You got what?
Good today.
Oh, it's good.
Yep.
You all get Jerry, President Jerry's forwarded silly science cartoons, right? And so we like to share them at this hour of the day, at the beginning of the show, get us in a light mood.
I think we could fill the whole hour.
Huh?
What?
I think we could fill the whole hour with them this time.
You see 7 or 8 of them. Some of them are about trick-or-treating. Others are about crashing into rocks. Dinosaurs are featured in a couple. And President Jerry, who's up for re-election like I am in December, is about to call something up from Tom. What does it say? Web person to everyone. Oh, blow that up. Ah, you've got very good eyesight. He's got a close-up of the moon on his easel. You know what? I didn't write that one down. I don't know why. Missed that. I remember seeing it. I thought maybe it was last week's. But the other guy wasn't.
Oh, that was very recent.
Okay. Here's a scene from an old Joan Crawford movie. He died of natural causes, she says. Well, you pushed him off a roof, lady. Well, gravity is natural. And Mink had to die for that coat. Now, here are some. Which one is this one? Ah.
This is ho-hum.
Ho-hum. Where is my ho-hum? I wrote it. Oh, a couple of space aliens have landed their spacecraft in a city park and approached the man sitting on the park bench, who is somehow not impressed. One of them says to the other, doesn't seem to grasp this man, the historical significance of the moment, you know? He's right.
He's had too many UFO disappointments.
Probably wearing a MAGA hat.
But the dog was happy.
Yeah. Where is clock to? Oh, here we go. NASA panics after the asteroid fires back. Yeah, we're getting a lot of those. We're going to talk a lot about this next week, I guess. And here is a rock that landed in the guy's living room right in front of him, still steaming, and he's trying to correct his wife. First of all, honey, it's not a meteor, it's a meteorite, for crying out loud. She's looking around the edge, and I guess something like that has happened, hasn't it? Oh, here's the guy.
Yes, it has.
A simplified cartoon based on a cold hard fact as the astronaut in space within his spacesuit floats toward the crescent moon, crashes into the dark unseen side. It's like a picture I saw once of the crescent moon and some stars were depicted inside the black part of the crescent.
Yes, I've seen that error too.
Have you? Yeah. People don't know.
This
And
is a repeated one, but it's a good one.
I like this. Buzz Aldrin says to Neil Armstrong as they climb out of the limb, "It's Alice Cramden." My God.
Okay, hold it. Who was Alice Cramden?
Oh,
The
you're
honeymooners.
Go ahead, tell him.
Jackie Gleason's wife on The Honeymooners, Tom.
It was a 1950s TV series, and he
Yep.
would always lose his temper, the husband, Jackie Gleason.
And what would he
Yell
say?
at him and say, "One of these days, Alice, pow, right to the moon."
To the moon, Alice.
That's right.
That's
Well, you gotta
terrible.
Well, you know who the youngest guy is among us. Here's something to be said. Me at my funeral, when I hear them say sell his telescopes, which one is this one now? What's the gist of this? Is there something missing, gentlemen, on this one?
The
No,
guy's
that's
getting
it.
out of a coffin, Ron.
He just stood up. He's supposed to be dead. They're burying him. It's his funeral.
You know
But he
what?
heard him say,
Okay, got it. Be at my funeral. All right. And here's a couple of dinosaurs sitting around. All I'm saying, Charlie, is now is the time to develop the technology to deflect an asteroid. Yeah, there they are talking away right before that. And here's home at the T-Rex household. I wrote this one down. Trick or treat. Halloween. Reptilian trick-or-treater at the door wearing a large craggy rock. Mrs. T-Rex opens the door, yells back to her husband, "Oh, look, Rex, it's a scary meteor." Probably the worst, most fearsome costume a dinosaur could ever see. And the real reason evolution started, this is another new theory out, having a fight with his wife. "Don't walk away when I'm talking to you." And the fish walks out and starts life on land. That's our great grandfather there. And back to this one again, close-ups of the moon. Great, got me in a good mood. Talking a lot about clusters these days. Haven't had a variable star in a couple of weeks. But let me ask my question real quick. Not opposition, occultation, which is something Chuck does at night involving tiny little specks of asteroids that you can't see, but it'll blink out a star. Isn't that technically a small eclipse?
Exactly.
So eclipse and occultation in the dictionary would be synonyms. About the
Yeah,
same
sort of.
definition.
Yeah. We sort of use eclipse for bigger things, I think.
Okay, well, we missed the Mercury occultation, which happened, this morning?
Yes.
Wow, tell us about it, Mr. President. What is that? Is that the moon?
No,
The new
well, the
moon
moon's in there.
Go ahead.
Who
The
was
moon's in
talking?
there. That's just an annular eclipse picture.
Yeah, I don't have a picture of the occultation of Mercury.
Did anybody go out to see it?
No,
No,
it wasn't visible from here, I don't think.
no.
That does
And
seem.
neither is the annular eclipse.
Yeah.
But this is an annular eclipse where the new moon is directly in front of the sun, but the moon is too far away to completely block the sun. So it's farther out in its slightly elliptical orbit.
So even if it were to go right across the sun would see the edge of it, right? The corona.
Yeah, that's what you see. That's the sun shining around the moon, and that's the most it gets.
Well,
But in this case, this morning, it would have been the moon passing in front of Mercury, but since there's no picture of it, here's an annular eclipse.
Right. Well, the paragraph is about occultations and an eclipse.
Yeah.
So
And when is the eclipse supposed to happen and where?
it's
Tomorrow.
supposed to happen in the Ukraine. It's an area that's tough to get to. It's not going to be for us.
Looks like it's stronger in Russia and Kazakhstan there.
Yeah. And so the darker color is where it's 100% on the moon. It doesn't on the sun. It doesn't mean it's going to block all the sun, but it's as blocking as it's going to get.
Yeah, 100% of the moon is on the sun.
Right. That's good.
So you better look at it through dark glasses, I guess.
Yes.
Boy, dark glasses may not be safe unless they're really strong ones, but yeah, you
Yeah.
want a solar filter.
Mhm.
Yeah. Well, I meant welder's goggles, actually.
Yes.
Okay.
Yeah.
So we get to miss out on both those. What have you guys been looking at recently, or have you had a good? I know you had a good time this past weekend. We had our big annual Kachuma picnic that's been delayed 2 years. Real quick report on that, Chuck.
Well, it was the annual camp out. We did it last year, but we didn't have the potluck and the catered dinner. But we did that this year. Yeah, it was really nice Friday night. I think we had 11 campers, which is more than it has been in quite a while. And beautiful night. And then Saturday, it was cloudy all day. And then in the evening, it was alternating between clear and cloudy. It was coming and going and, sucker holes here and there. But when it wasn't cloudy, it was decent. There was a lot of wind, so planetary was really wiggly, but deep sky was okay.
Okay. I remember those long tables, those picnic tables. At
Them and the spiders are still there.
Did you take your dog, Mr. President?
No.
Oh, no. You didn't make it. Did you make it?
I was there for the dinner.
Well, I got offered a ride by Tom Totten, and
it got very cold and very windy Saturday night, but everybody told me that Friday night was very clear and I missed a good night.
Yeah.
Well,
so.
And what was weird about Saturday night was it got really cold and windy. And by about 9:30, the sky closed up and everybody just gave up. I got up around 2:30 and it was actually warmer. It was still clouded over. And then after that, it got real cold again. So there were waves of things going by.
Does that picnic spot, was it on the coast, the edge of the water at one point, and now we're way far away from the lake?
Yeah, in years past, the lake came almost right up to it.
Is there a dock there?
There is a dock there, but now there's also now a concession for people who want to go rowing on the lake. And they store their boats right next to our campsite there, next to the firefighters. And they have a long walk to get to the water.
And you can't swim in the lake, because that's our drinking water, I guess.
Right.
Tom just put a note on. You want to mention, Tom, about comments from viewers? Questions?
Well, Tim Crawford is saying at Westmont they had Saturn and Jupiter up for at least 5 minutes.
Welcome, Tom. Okay, so nobody saw Mercury get a cult, and we won't see the eclipse later. How about talking clusters are us again? Can we go there, Mr. President? With the white rose, I never heard of that one.
Oh, this is the white rose. This is the northern skies up near the Polaris is off this way. The W of Cassiopeia is this line of stars here. Up near Calf, right up here, is the white rose cluster, which is NGC 7789. It's quite a bright cluster. It's small. It's only about 15 minutes of an arc across. And it's magnitude.
I've shown that a lot, Jerry.
What's that?
I've shown that a lot at Westmont in the refractor.
I'm sorry, I didn't hear you.
Oh, I've shown that one a lot at Westmont through the 8-inch refractor. It's just absolutely beautiful.
Yeah.
On a good night, it just scintillates. Carolyn Herschel discovered it.
Yeah, I've often heard it called Carolyn Herschel's rose instead of just the white rose.
Right, that's the way I've heard it.
The white rose always reminds me of a bad event in history when Hitler was taking over Germany. Two students from the University of Berlin wrote a flyer opposing him and criticizing him, and they sent it out. They distributed it, and in a few days they were arrested and executed for opposing him in print.
And they call themselves the White Rose Group.
They called themselves the Society of the White Rose.
Yeah.
Wow. So this looks like a white rose, I guess.
It does. It has looping structures of stars.
Yeah. Is the Cassiopeia W considered an asterism?
Yes.
Say that.
Yeah, the W is probably an asterism.
Yeah, the pattern that you recognize, like here, the W shape, or at other times of the year, the M shape, is an asterism.
Asterism is a very generic term, so essentially every constellation is an asterism.
Yeah, that's true. But your notes, your talking point said it would be rising right side up. It doesn't look like it. It looks like it's on its side.
This is not exactly at the rising time. It depends. It goes around the pole.
Oh, that's
At our
true.
place, it's almost always in the sky. This, I don't remember which way this is looking. Let me see if I can. This is at tomorrow night at 8 p.m.
Mhm.
So,
That'd be kind of northeast.
yeah, northeast. So it's rising. So earlier than this, whoop, where am I going? Oh, there. So earlier than this, it would be down here. So it's losing its W-ness as it rises up. It turns over when it gets way up there, it'll be an M.
Right.
Well,
And the constellation is a queen sitting in a chair, and she rises upside down. If you take what's that one star there? Is it NE something?
Navi.
Navi.
Okay, if you go to the dimmer star above and to the left of that star,
Shader. Oh, left. There.
right there. Yeah, so that forms that forms the sitting portion of a chair, Jerry. Okay, and the queen is up. The queen comes in upside down, and her head is down to the left and lower from there, right in there somewhere. Yeah.
so a chair would be a throne then.
Yeah.
Yes, it is the throne. She was the queen of
She's
Ethiopia.
upside down. She's hanging on for dear life, this part.
Yeah, right.
And then Kaf and Shadar are like legs of the throne. And then that
That's-
other star down from Shadar is another leg of the throne. Not
Right, and
Rukba,
Oh,
but the
this
other
one,
one. Yeah.
this one.
Yeah, and then the back goes from Rukba up down to the left.
Yeah.
That's the back of the throne or chair.
What's the name of this star? Do you know?
Off the bat, I don't know, Jerry.
Okay.
Yeah, sorry.
Well, historically, was Andromeda the daughter of Cassiopeia?
Yes.
Yes.
Cassiopeia was a queen at one time?
It's mythical.
I think it's mythology.
Oh,
Mhm.
Greece then, right?
No,
Yeah.
Ethiopia.
It was Greek story, but they were supposedly royals in Ethiopia,
Mhm.
Right.
which is kind of the term the ancient Greeks used for all that area of Egypt and Ethiopia and Somalia.
Mhm.
Was the Andromeda galaxy close to Cassiopeia?
It's right
There's
down
the-
here.
there's the image.
Cassiopeia ends here, and this is the central star of Andromeda, Merak or Alpheratz. But this is Andromeda around here.
Yeah.
And
If
see-
you have a good telescope, Jerry, I'm sure you know this. If you take say an 8-inch telescope and focus it on Merak, there's a galaxy way in the distance. I can't remember the NGC on it, but it's often called the Ghost of Merak. It's really pretty. I think it is an elliptical, but I'm not really sure. Chuck
Yeah.
may know.
Yeah, I don't remember it. To me, it looks almost lenticular, but
Yes, yeah. And I think it was what's his face, the guy in Hawaii. Jerry met him. That
O'Meara?
called it. Yeah, O'Meara. Steve
Steve
O'Meara.
O'Meara.
Yeah, he's the one who named it the Ghost of Merak.
Okay. So Merak is halfway between M31, the Andromeda Galaxy, and M33 in Triangulum.
Yes.
Both very nice galaxies.
Mhm.
And M31 is much brighter. M33 is bright too, but it's spread over a big area, so it's actually fairly dim. Let's see if I can shrink it. The Polaris is right here, and it's an easy star to spot. And you take a line right through the middle of Cassiopeia, and it comes out with Merak. So that's the easiest way to find these two galaxies,
Mhm.
starting from Polaris, in my view. So
On a good night here, I can see M33 with just
naked eye,
binoculars.
yeah.
Sometimes I can actually see the darn thing with my naked eyes if it's pretty dark.
Well, can I ask a question? Putting up your telescopes, gentlemen, when you zero in on a star cluster, what do you see? Just part of it? Can you get the whole thing inside the view map?
depends on your eyepiece.
Yeah, right.
Depends on your depth of whatever. Interesting, because
You put different eyepieces in to get different magnifications. And if you have a low power eyepiece in, say a 1-inch eyepiece, you generally get near the maximum field of view that you can get with your scope. And you can go up to like 5 or 6 millimeters of focal length and get a high magnification. If your telescope is aligned properly and figured right, you can get a good image, but it's very narrow field of view.
And also in general, the longer your focal length and the bigger your telescope, the narrower your field of view is.
Yes.
But you can't focus in on one star among thousands.
Oh yeah, you can.
Oh,
Sure.
you can. And most of them,
As you focus way in, your image generally goes to hell,
Yeah.
depending on the seeing and the eyepiece and all sorts of things.
Hey, Jerry, I wanted to mention about the other names for Polaris, since we got Polaris mentioned. I like that name, Stella Maris, and then also Lodestar. I'm not sure what does lode mean. I mean, Stella Maris means what, the star of the sea.
Right.
And I assume that's because the mariners would use that for their latitude on the planet. And then lodestar. What does lode mean? Anybody know?
Lodestone is what they used to call magnetic rocks.
Right.
And so lodestar would be the lodestone points to it.
so they used to dig up rocks that would attract metal.
So early compasses would point to Polaris roughly.
Yeah.
Ah,
From here, it's about 13 degrees off, but yeah.
even though they had no way of recording the turning sky, they could tell which star just stayed in place.
Yes.
Yeah.
If they could see the stars, they could always guide by them. Polaris was their favorite for the Northern Hemisphere.
Yeah. If magnetic north were always coincident with the geographic north, all compasses would point right to there, but that's not the case.
Now, the Vikings had a stone, I believe it was calcite, that was birefringent, and they called it a sunstone because on a cloudy day, you could look at the sky through it and it would show you where the sun is.
That's pretty neat.
So that was a secret navigation thing for them, along with magnetic compasses at first. They tried to keep them secret.
And what star is going to replace it in a few million years? Vega?
It's not a few million.
No,
12,500, I think.
that's right. That sounds right.
Hey, Tim just piped up and texted me. Mirac's ghost is NGC 404.
Okay. Thank you, Tim.
Meroc has a NGC number. Oh, the ghost galaxy.
The distant galaxy, Jerry. Yeah.
Okay. Okay.
Well, Jerry, before you decide to go what's next on your talking points, maybe you could lump together all the other references to star clusters, like the Continuum and the Westerlund 2. Is it possible we could talk star clusters all at once and you can jump ahead?
Sure. We'll give it a try.
Because in between is the comet and the Orionid meteor shower. Here we go. And that's Miriam.
Yeah. Too fast?
No,
Okay.
those are coming attractions.
This is a picture from, this is not the star cluster thing, no. You wanted star clusters.
Yeah, let's, well, depending on, star
This
cluster.
is Westland, what is it?
It's a beautiful one in the south.
Yes, it's in the south. And why the heck are we looking at things that are way in the south?
Okay.
Are we looking at it now? That's Westerlund 2.
This is a huge star forming region with supermassive stars in it.
Right. And it ties in, actually, there are a lot of Wolf-Rayet stars in here. So it ties in with the story above it, but we'll get to that.
Okay.
So the point of this is, the reason I put it in, is that this image was taken by an amateur in the northern hemisphere from the, I believe it was the Hubble telescope. Yeah, Hubble Space Telescope. The stuff that the Hubble takes and the JWST are online. They're available, and there's a program you can download for free called FITS Liberator. And FITS is the name of the format these pictures are stored in, like JPEG or TIFF, but it's stored in FITS. And so you can take these FITS and use the FITS Liberator, and you can then put it into several programs like PixInsight and Photoshop. And you can develop these pictures yourself. And this is what a guy named John Bozeman does. He goes and gets Hubble pictures and takes it. And so the people that are interested in processing images and practice processing, then any amateur can do this. And the pictures are available from all over the world, Southern Hemisphere, Northern Hemisphere. And a lot of people don't use their own equipment to take these. They go around to the big observatories and get pictures that they took and they process them.
Yeah.
Because
when Jerry says the picture is available, he means sort of the raw data that forms the image. And then people process it in these other programs to decide what color goes where and you know, how to take out gradients and stuff like that. So they're the ones that make it into something pretty.
yes, good point. And I would like to add also that scientific instruments like Hubble and JWST, they don't take pictures in the same bands that amateurs do. We tend to do what's called RBG, red, blue, green imaging, like your cell phone camera does. But those are not the bands that Hubble looks at. The filters on Hubble are more, and on JWST, are more geared towards specific scientific information. And this, for example, is the filter wheel on the JWST for the mid-wavelength infrared imaging. And so it looks at all these different wavelengths that pass through these different filters. And then it puts together, because it gets the relative brightness in each spectral band, gives you a spectral response to that, and it tells you what's there. You know,
Yeah, each one of those circles you see is a different filter passing a different set of wavelengths.
Right. So this one is a filter, this one is a different filter. So the detector is back there somewhere, and then this rotates to cover the sensor with that filter, and then you see the sky in that color. So this rotates from different filters in place. We do a similar thing, but on a much smaller and much cheaper scale. We take monochromatic cameras and we put like a 4 or 5 position filter wheel in front of it. And then we can control that by computer, which filter is taking pictures at that time, which filter being looked at by your telescope at that time.
But still, all of those circular filters are within the infrared spectrum only?
Yeah, they're all within the infrared. There's no visible filter here, even though you do get a visual effect of the color here. But your eye is not the definer of the wavelength there.
Yeah, and in fact, the color you see on those filters is the color that's being rejected by the filter.
Right. Just like green plants who do photosynthesis, absorbing red light from the sun, and then the green is left over, so the plant looks green.
Is that a robot or a man in the upper left? I'm trying to figure out what that is.
Well, this isn't gigantic.
Oh, okay.
This is an arm. There's a little counterweight there, and it goes over these rollers to position it and lock it into place, and a little motor to make it move around. And then its electrical connection is over here.
And it's MIRI, mid-infrared instrument. Somehow they get
mid-IR imager.
Oh, imager.
Yeah.
So Jerry, what are those filters that just have cross pieces going around? I mean, if they're not like.
You mean like these?
There's probably an occulting bar in there for blocking out a star.
Yeah,
like
there could be.
Like the one next to the red one there.
And
yeah,
one
actually
of them
says 4 filter diaphragm sets for chronography.
Yeah.
Chronography.
Yeah.
And one
So
double
that would be the
prism assembly.
coronagraphing.
And one double prism assembly for low resolution spectroscopy. I can't even say that word.
Spectroscopy.
Say it fast.
GCLC
I
show.
was looking to see if one of them was a Batinoff mask, but there's none in there.
Well, there's been some great pictures coming back from Jupiter, and it's even close up, like the Juno, you know, that, and yet it's the Webb. Can the Hubble not take pictures like that?
No, there's lots of Hubble pictures of Jupiter.
Yeah, and they're good pictures. The Hubble is a smaller telescope than James Webb.
Well, I know that, but the pictures we've been seeing recently are from the Webb.
Yeah.
Yeah.
they're colorless because of, I guess they haven't been colorized and it's infrared, but still it's close up of the big red spot and you see the surface turning real fast.
Yeah.
10 hours.
I don't, that's probably not James Webb.
I'm pretty sure it is. It's billed as such, but I've never seen anything like that close up from Hubble.
I've seen it pretty close up from Hubble.
Yeah.
It's pretty clear.
The ones you see of the spot and the swirls and all that, those are from Juno.
Oh, they are. Well, can they do the same thing with Uranus and Neptune? Saturn?
Yeah, the James Webb did Neptune just recently.
Yeah. And one of the Voyagers did Uranus as it went by with a very dramatic picture.
Could even see the rings. Those gas.
I don't recall the rings. One of them was taken with a very nice crescent phase as it went by. It's just a beautiful picture. I got a big copy of it and put it on my office wall in graduate school. So now where was? Well, let's start talking about this since we're on James Webb.
And Tim likes Wolf-Rayet stars, so.
Okay. Well, we'll see what I know about Wolf-Rayet stars. So this one is a picture from the Hubble, from the James Webb. The actual image has the 6 spikes of diffraction going off. You can see very faint traces of them here. But this image has been processed to remove those spikes. And so what you see is just what's considered the image, the Astro image. And these are spiral rings that there's I forget, 17 of them. But before this, when the Kepler looked at this, it only saw 2 of these rings here and in here. This is a dramatically better thing, and it gave them a picture, and it gave a great, they worked out what's happening here, and apparently it's a pair of stars, a Wolf-Rayet star and an O star, O-type star. O-types are very hot. They're blue, and I think the surface temperatures of these 2 stars are about 38,000 degrees, where our sun's about 5,000 degrees Kelvin. This is the size of the sun compared. So these are big stars. This one, the Wolf-Rayet star, throws off a lot of crap because it's got a lot of convection in it that brings, and we'll get to what they're made out of in a minute. But this is how the 2 stars are viewed as orbiting each other. They are, both of them, when you see them, it looks like one star from far away. And they're both referred to as Wolf-Rayet 140, but only one of them is a Wolf-Rayet star, this one here. They orbit each other every 8 years, and as it goes by here, it pulls, the O star pulls stuff off the Wolf-Rayet star.
Well, Jerry, I think you're mixing the 2 up because the O star is more massive, so it would be the one with the smaller ellipse. And so you're right. The stuff, yeah.
Yeah, thank you. So anyway, this creates the ring as it goes around. So, and this is a sketch or an artist drawing of the 2 stars producing the ring with a lot more of the ring showing. The other one was also a diagram. It wasn't a photo. And the only photo we have is of the spirals going out, looking face on at them.
Yeah, and it wasn't resolving the pair of stars because they're really close at their closest.
That's right.
It's like it's 1 AU at their closest.
And this is why this is particularly interesting, because the stuff thrown off by the Wolf-Rayet star is a mix. It's very highly metallic in its mixture, and it's what you need. So this is a hypothetical or theoretical cycle going from the Wolf-Rayet type stars throwing a lot of crap out, and that congealing into what do they call, stellar nursery, that then ends up collapsing into a disk, forming a sun and planets, and then that's how the solar systems start. So the composition of this starting point is very interesting. Whoops, we're on that. And the stuff that's in there, Chuck, do you remember what the spectral is?
I think it was nitrogen and oxygen that they're seeing coming off of the WR stars.
Oh yeah, it's polycyclic aromatic hydrocarbons.
Oh, that stuff.
That's the-
PAHs, yeah.
Yeah, that's what the shells are made out of, PAHs. So they're very carbon-rich compounds.
Barbecue gunk.
So hold it.
Barbecue
Aren't these stars pretty hot and new, and they're
Yeah.
just burning, they're just fusing hydrogen? So where's all the carbon stuff coming from?
Well, they're very massive and they're forming that stuff quickly.
They're
But for
burning-
some reason, these Wolf-Rayets have a lot of turbulence inside, a lot of convection going on. It brings it to the surface, and then they're radiating so powerfully, they kind of blow that stuff off.
the
So
surface,
is
Go ahead.
helium fusing into carbon inside that star?
no,
Yeah.
helium is fusing on the surface. The other stuff is fusing in a hotter core, but it's convecting to the surface.
Well, yeah, you got like an onion structure. So you've got different
Right.
levels of fusion going on. But with the convection, it kind of dredges some of that stuff up to the surface and where it gets blown off.
Yeah.
I just always think of, you do the hydrogen fusion to helium first, then helium into carbon next. But
Yeah.
you're saying there's multiple stages going on, huh?
Yeah. In a low mass star, you have just one of those, generally just one of those going on until it starts quieting down and it shrinks enough to get temperatures and pressures to start the next one. But these guys are so massive that you have oftentimes a whole sequence of that stuff going on at different shells. At
In
different
parallel, right. So as Chuck points out, it's barbecue gunk, PHHs, PAHs. It's also what's on burnt toast and in the exhaust from automobiles.
Not so
Without a
aromatic
catalytic
sometimes.
converter.
So these PAHs produced by these stars enrich the carbon content throughout the universe and are the basis of life on Earth.
And a lot of that carbon comes out because the carbon, gets out to the surface and it's able to condense into structures, molecules and
Yeah.
structures at fairly high temperatures from our point of view that then are more opaque to the radiation and they get blasted out.
So the Wolf-Rayet is the larger circle. It's the one that sheds its dust and stuff. The big
Big at the
heavy
upper
one-
left there.
Isn't it the one going around the big
No,
block?
this is not an orbit. This is an evolution curve. First this occurs, then it turns into this, then it turns into this, and these are billions of years between each of these steps.
But would it be fair to say that each one of those rings gets made whenever they come close together?
Yes.
Okay.
So
and-
this star is peeling material off this one, and you can see it started the curve. Now this is a theoretically generated diagram. This is also a theoretically generated diagram. The dust is coming largely off of this star. So
It's a complex interaction. And I think
yeah,
that diagram, especially that one we just passed there is misleading because I think it's conflating the more massive star and the Wolf-Rayet.
which one?
Because-
This one?
Yeah, because they put a big blob for the one. I mean, this is the more massive one making the smaller oval.
Yeah.
So
This
that's
one
not the
is-
Wolf-Rayet.
This is a single frame from a movie, a video
Uh-huh.
that shows this thing. They're quietly circling each other, except as this one starts here and goes off, it pulls dust off this one. And then it goes around and then it doesn't do it for a while. So
What did Tim Crawford have to say, Tom?
He's got a couple questions. Don't the Wolf-Rayet stars have emission lines versus absorption lines? I mean,
They'd have both.
yeah,
it both.
gives
And
a
then he
unique
also had-
spectrum.
And then he asked, I'm not sure how he meant this, not as bright per their temperature. Not sure what he means there.
I think he's hinting that maybe the cloud of stuff they're emitting would cut down on the brightness.
Right, yeah.
What the heck are emission lines?
Emission lines are the bright lines you see in a spectrum. Absorption lines are the dark
Oh,
patches you see in a
oh,
spectrum.
those kind of lines, I see.
Yeah.
But we counted 17 rings.
Something
That
like
was,
that.
I didn't count them, but that's what the caption said.
So where's the habitable zone around those stars?
Way out there.
It's here, we're in it.
Yeah.
Do they
And,
have?
you know, they might have resolved it there. That it doesn't definitely look like a single star in the center.
Well, there's a brightness here at this
Yeah.
end of the thing, and there's another brightness there, but I don't know.
Yeah, well, it looks like they've resolved it. That little one would be the smaller
Yeah.
one is giving off that nice little ring, you know. Well,
Yeah.
But those rings are not going the speed of light, right?
No.
no.
And they're solid, they're matter, but how often? How many years between rings?
8 years.
8. Every 8 of our years, they get close. So that's when the binary gets together.
Yeah.
Okay.
And you notice part of them are missing.
Part of what are? Oh yeah.
See, there's none up there.
Huh.
Do
That's
you think that
because-
might just be blocked by a cloud?
That's because when the star continues out here, this dust continues on out, but the new part is not generated until it gets close in again. So only in this part of the orbit is the dust cloud generated.
If you didn't
the
have a
rings-
binary there, it would just be a diffuse cloud around. But the fact that they're orbiting like that causes these density variations.
Right.
Well, I've got an offer for Mr. Crawford if he's listening. I could use a third speaker for 20 minutes on December's first Friday meeting, and if he's an expert on these stars, these Wolf-Rayets, we'd love a little presentation.
I think he's asking the questions about these, just clarifying things.
Well,
Well, he said he likes them.
yeah, well, if that's his specialty, I think this is fascinating. And you two know what you're going to talk about, Jerry, Chuck?
Yes, I'm going to talk about building my observatory real briefly.
Oh, that's right. That you told us that.
And if you do manage to get another speaker, I'm not going to speak because people are tired of me.
No, we're not.
So what are we looking at? Is this the Westerland 2?
Yes, this is the Westerland 2 taken by Hubble. It's in the south. It contains some of the hottest, brightest, and most massive stars known. The cluster resides inside a stellar breeding ground, or a nebula, called GUM 29. I don't know where the word GUM comes from. I guess it's someone's name.
I think it's an astronomer's name. Yeah.
Yeah, okay. It's located 20,000 light years away in the constellation Carina. It contains the naked eye Cepheid variable V399 Carina, and it contains at least a dozen early O-type stars, of which at least 3 are eclipsing binaries, just like Hubble or like the JWST saw. But this is not where it saw that picture from this cluster. I don't think. So the O stars are hotter than 38,000 Kelvin, and they're more luminous. They're 230,000 times brighter than our sun.
Wow.
Well, can you answer me this? Are the stars in a cluster orbiting pretty much around each other as they go through the roundabout of the Milky Way, or do they all just move alongside each other?
They're orbiting a common center of mass.
They are. Okay, depending on how far the stars are from that center, does it reach a point where then the other stars are outside of it and not part of the cluster, I guess?
They evaporate.
Wow, but this is it for the Westerland. It looks like only a couple dozen.
They're all very bright stars, very hot. It's unusual. You've got a lot of mass packed into new stars. Most of the stars in our galaxy are red dwarfs, or what is it, brown dwarfs, or
Red dwarfs.
red stars. But this one has a large cluster of extremely bright and massive stars. They will burn fast and produce a lot of metal atoms.
I
And
did a
they're-
quick look up. Colin Stanley Gum, Australian astronomer, known for cataloging emission nebulae.
Okay. Okay.
He's got a little brother named Bubble.
Yeah.
and what? Now tell us the 29. What does that mean?
29.
29th
What?
in his catalog.
Oh, the 29th nebula he found.
Oh, I see what you. Yeah.
But now a giant star that's blue is super hot. What about a Betelgeuse, a giant red one, a red giant? Is that not as hot?
Not as
It's
hot.
cool.
Nowhere near as hot.
The color tells you the temperature.
Just like if you were watching a blacksmith heating a piece of iron, you know, first you don't see a color to it. As he heats it up, it gets red hot. Then it gets brighter.
Yellow hot.
Yeah, yellow hot, then up to white hot.
Well, will these giant blue zero stars or O stars get red and begin to implode eventually? We're going to have a...
Well, yeah, they're going to go through core
Same
collapse
thing.
supernovas.
Supernova, that's the word I was looking for. Wow.
Yeah, this is going to be like a machine gun going off of supernovas someday.
And they're young, relatively speaking,
Yes.
a million years old. Wow.
Well, I think these stars are Betelgeuse used to be like one of these big heavy stars. Perhaps I'm not sure the mass difference between Betelgeuse and these O stars, but yeah, and their lives are very short. The larger the more mass of the star, the lives can be down less than 10 million years compared to a 10 billion year life for our sun. That just always amazes me how short a star life can be.
Live fast and die young.
Yeah.
But we don't know. We don't know.
If you
For
eat too
example,
much.
go ahead. I'm sorry.
If you eat too much and get really massive, you can live fast and die young. Yeah.
Do we know in our search for exoplanets that giant stars like this might just have planets like Betelgeuse? Does it have planets around it, you suppose?
We haven't found any around it. It's tough because when they're in that stage, they have a lot of convection and they bubble and boil. And unless you get a really big one that's eclipsing it, that's occulting or that transiting it.
Well,
hard
chances
to
are it
detect.
ate up many of its orbiting over the years, didn't it?
Yeah, we do see stars that show evidence of having consumed planets.
Wow.
But usually it's the case that the planet spiraled into the star.
At the very end of Jerry's talking points, apparently there are all kinds of new star cluster categories, some that aren't even in the Milky Way. Is that a fair statement? Superstar clusters?
It's not exactly the point of that, but the idea is that for all the time I've been studying star cluster, this article makes the point. It's from an Astronomy magazine thing a few years ago, I think. But it makes the point that even though we think of clusters as being of two types, open or globular, and that does tend to be the case in our galaxy, that now that we look in other galaxies far away and we can see and resolve the clusters in there, it's more of a continuum. There's no sharp divide line between open and globular. And so
it's a typical science thing. It's just like dwarf planet versus major planet or asteroid versus comet.
Yeah.
It's not a sharp definition. There are things in all those
Mhm.
gradations.
Well, what's the difference between open and the other one?
Globular.
Globular. What is that?
In our galaxy, the globulars are old stars and they're in really massive, huge, very populous clusters. And open stars are young and they're in more diffuse clusters.
But would it be safe to say that very few of them, if none of them, just collected together, they all started in giant nebula, right? Of dust and clouds.
Yes, they all started in a nebula.
Okay.
I listed under the view from within the aspects of open clusters and of globular clusters as we do them in our galaxy. So you can see the two bullet lists of what the differences are.
All that brownish red on the right side of this picture, is that a nebula?
Oh,
Just gas.
yes, it is. That's the GUM 29 nebula.
Oh, that's the gum.
Yeah. This is a plot of brightest young clusters within the Milky Way. Oh, this is within the Milky Way, I believe. NGC times or no, this spans a number of galaxies. But you see up here, let's see, which it doesn't say which one is the triangles and which one is the dots. Circles.
The dots are open clusters. The triangles are what we call globulars.
Globulars, and they tend to hover up here in a certain region of age and metal content. So these are less metallic, more hydrogen oriented, and they're much older stars, the ones that are in true globular clusters. And these are the ones in our galaxy where we have measured them. So these are, for example, NGC 288 right there. That's in the Milky Way. These are open clusters in the Milky Way, and you can see that they contain much more. They're produced from a nebula that had more exploded stars or carbon or whatever in them, and they are younger stars. They're down here between up to like 6 billion years, 8 billion years for the most of them. But they do overlap a little bit, even in our galaxy. So here, Terzan 7 and Pal 12 are across the gap into the open clusters, and here BE 17 and NGC 6791 are much older than the mass of these things. But this is much more emphasized in situations outside of our galaxy where something has happened in the galaxy. There's been a collision or two galaxies interact.
Would it be fair to say, Jerry and Chuck, that inside clusters you'll find the same cross section of things, from magnetars to brown dwarfs, red dwarfs, red giants, or are they all pretty much the same? They're all big.
You know, initially you would have fewer of the more evolved stars, but then as time goes on, you'd get more and more of the red giants. That's after some amount of time of life of a massive star. But of course, that lifetime is short. So in a relatively short time, you'd start to get those.
My impression is that when they form, you tend to get things that are pretty much alike in the same nebula. So if the nebula is very, very dense, you may get a lot of O-type stars like we saw in Westland. In other places, like where the sun came from, we have probably had a lot of solar type stars. So, and that's, I think it's dependent on the composition and density and mechanism that stimulated the star production or star growth.
Yes, and the larger, if you get a rapid formation of the massive stars, which you would in a very dense environment, their winds blow away the material to make the smaller stars, and they kind of quench star formation.
I think I've asked this question before, and I think I know the answer, but if our sun and our solar system were in a cluster, would we have a dark night sky at all, or would we just be bright?
If we were in the middle.
Of a globular cluster, it would be bright, but open clusters are a little more, less dense.
And there may be a black hole in the middle of all of them, most of them, few of them.
Well, we found black holes in some of the globulars, but not necessarily all of them.
So this is an example of open clusters in our galaxy. This is the double cluster in Cassiopeia.
We were looking at that over the camp out.
Are they orbiting each other?
No. No, they're both orbiting the center of the Milky Way, let's put it that way, but they're not rotating around a common center.
Oh, so they're going side by side.
Yeah, more or less.
One of them is about a couple hundred light years in the foreground.
Yeah.
Wow.
There's some really nice red giants in this cluster, not so many in this. And a globular cluster, of course, is like M13. Nice color in this. It shows the blue ones and the red ones. But one of the most interesting things, globular clusters don't work. Open clusters tend to follow the arms of the Milky Way, and they orbit in the plane of the galaxy. Globular clusters don't do that. Globular clusters are like the Oort cloud. They're in a circular shell around the galaxy.
Really?
So they pass through the galaxy, and this is a highly dramatized sketch of a globular cluster passing through the plane of this galaxy. And when it passes through there, it gets disrupted. It initiates, if it collides with a nebula, it initiates an open cluster and stellar formation. And also it gets disrupted in orbit of the stars around the center of the globular cluster. And you can see these things. There's some some globular clusters that have been viewed, and they show on the leading edge, they show stars being thrown off ahead of the cluster's orbit, and other ones with the stars trailing behind it. So they're getting it when they get disrupted and pass through the plane of the galaxy, they start losing their stars. And so globular clusters will eventually evaporate.
But an interesting thing, even if they don't pass through the plane, they evaporate over time because they're so dense that the individuals interact with each other, and you get interactions that throw stars out. But as they throw out the stars, they sort of get more compact. And so they may throw out stars and end up looking brighter and denser because the central part of them gets very, very much denser.
But they're not as big as our satellite galaxies, like your Magellanic Clouds and Triangulum.
Right. Well, Triangulum isn't a satellite galaxy of ours, but yeah, some of them look like they're the cores of galaxies that we've gobbled up.
Yeah, we have about a dozen or something small, hard to see satellite galaxies that are basically torn apart. The biggest ones are the two Magellanic Clouds that I know of. But there's a number of other ones, and they look like it's been speculated that globular clusters are actually remnants of core small galaxies that we collided with. I don't know if there's scientific proof of that, but it's a speculation.
What are we looking at now? A galaxy or a cluster?
It looks like M33.
Yeah.
Oh,
It's showing regions of star formation. The red stuff are nebulae.
well, gentlemen, can we cover two items before we're just about to close down here? Comet C2022E3, where it's going to be, and then the Orionids, are they still active? Can we cover a couple of quick things real fast in the last 2 minutes or so?
The Orionids are not real active right now. We're on the the peak was on Friday morning, but we saw some nice ones on Thursday evening when we were doing Hope School, and a couple of nice ones at the camp out, but nothing spectacular.
Yeah, well, I found a video on that was live, a live camera at night on YouTube, and every so often there'd just be a streak on the sky. So, and then the comet is going to get brighter and closer in January, the new year.
Yeah, don't look for a dramatic scene here. It's 11th magnitude now. Here it is traveling through Corona Borealis into Serpens Caput, and it's 11th magnitude. You can see the numbers on there. You probably can't see them, but it's those are the dates. 10
dates in October.
Yeah, and so right now it's down around here. Is that right? Yeah, 27. No, this is 25. So it's right here, and
this is one of those horrible astronomy star maps.
Well, this is the same thing I use. But they blew it up way so much. This is from the Sky X. So I was hoping, I usually try to capture the wider field so you can see this too, but I didn't. So
Jerry, I got to ask,
fairly low in the west, so you got to catch it before too late.
Yeah.
What's with the name Serpens Caput?
Well, you got Ophiuchus, the serpent bearer. Okay, and there used to be there's two constellations associated with the snake that he's holding. Serpens Caput is the head of the snake, and Serpens Cauda is the tail of the snake.
Right from the Latin, Tom.
What does that mean? Oh, head
It's
and tail.
it's also where the word cap came from.
And what's that word?
I just made that up, but it's all right.
Caput is the head and cauda is the tail.
Mhm.
And when a pianist plays, signs off basically cadenza, little tail in Italian.
What is the string of beads vertically in the middle of that? What is that?
That's the position of the comet.
That's
Right.
Oh, that's what that is. Okay.
This is where it is right now on 1025. Here it is at 1030, and this is getting on into November. So it doesn't move very much.
And the old comet Pan-STARRS is pretty much gone or going away.
Yep,
Ron, there are tons of Pan-STARRS comets, but yeah.
Well, that's the one that came down through Jerry's talking points all these weeks.
There was a Pan-STARRS that was bright.
So they didn't have a regular name for it, or we just didn't
Yes,
get
they did, but you have to say it's C2020F5 Pan-STARRS. You know,
Yeah.
it needs a serial number.
Why don't the astronomers just give their last names? That's what they used to do.
That's the Pan-STARRS.
Pan-STARRS is the system that discovered it.
Right.
Oh. So what happened to Hale Bopp and McLeavy-Levy or whatever?
Oh, it's still out there.
Yeah. Well, it's just that amateurs are making fewer of the discoveries because
Right.
the automated systems catch these comets way out there.
I got you. Do you anybody know when Halley's is coming back?
2061.
Oh, okay. We won't be around for that.
No,
Oh, yeah.
Might be
so
around with
pessimistic.
titanium parts.
So this is Mars in the morning near Orion. This is where the Orion meteors will appear to come from, but you can get them all over the sky. As Chuck points out, it's petering off.
Yeah.
But between midnight and dawn is when you're likely to see a meteor. This is Mars, and Mars is it's within 2 months of being at opposition, which is
It rises about midnight, Jerry.
Yeah. Okay. What time is this? This is midnight. Yeah. And it's just risen.
Our clocks are good.
Yeah.
Well,
I
Chuck,
think we change time this coming weekend, don't we?
It's getting close,
back-
like 6 or something like that.
Back to daylight waste time.
Yeah.
all back. That's when we lose it. We lose an hour, right?
Yeah.
All back.
We gain an hour of sleep in the morning.
Chuck, real fast. Did you guys see any meteors over the camp out?
Yes.
Yeah.
Uh-huh. The
Oh,
brightest
you're-
one I saw was actually on Thursday night. It went across like 3/4 of the sky. There was enough time. It was perfectly timed because there was a group of like 45 kids that had just gathered. And I was telling them, don't touch the eyepiece, this, that, and the other thing. And there was enough time for me to say, look, there's a meteor. Get out my laser pointer and point at it. And all the kids got to see it. It was so long lasting.
Wow.
Wow. Does science know if it's a grain of sand, how big does the ball of fire it creates have to be for us to see it?
Well, grain of sand will do it. It's the speed that it's entering, the velocity it has.
Yeah.
I know what causes it. I'm just wondering, are we looking at just a little streak that?
Yeah, those fast white little streaks are usually about a grain of sand.
Yeah, this one might have been maybe a ping pong ball.
Okay, but how wide does it have to be for us to see it? Why
Grain of sand. You don't see the size, you see brightness.
I know that. Okay.
Well, and the brightness is not the object itself. The brightness is the ram heated air in front of the object.
Yeah.
That fluoresces.
Hey, Ron, there's also something exciting that Tessa saw on Saturday night that Chuck found with his telescope in the sky. Chuck, can you describe that?
Oh,
It was a classic UFO. The sky was still bright. We had just grabbed Jupiter for a couple of people to look at. And Tessa said, well, what's that bright thing up there if the other bright thing is Jupiter? And it was where there's nothing bright, at least bright enough to show through a blue sky. So we cranked the scope over onto it, and it was your classic UFO. It was a gigantic weather balloon with a radio sonde attached to it by a cable. And the angle of the sun was just right to show up the cable and the radio sonde and the balloon. And we caught it just before the balloon rose to a height where it got big enough that it blew up.
So it was way up there.
Yeah, and it was really spectacular.
Well, I'm sorry I missed it, gentlemen. Me and my car are back together today, and we will get together next week for number 88. My God, we've been getting together that long.
Hey, keys on a piano, constellations in the sky. And what are the teeth in a porpoise?
He's on
What'd you say,
Okay.
Tom?
keys on a piano. 88.
Okay. All right. Well, thanks for teaching me some new stuff, and we'll talk again in a week. And I guess we'll see you, Jerry, in 2 weeks.
Yeah.
Day off, and Tom Totten will be running things. Give my love to your wives, and we'll see you next time around on Monday mornings, 11 a.m. The SBAU Astro